Hello students, welcome to today's session of chemistry. As you all know, we have started studying fifth lesson of your syllabus, that is electrochemistry. In the previous session, we learned about the process of electrolysis. Before that also, we learned about the electrolysis of fused NaCl and that of aqueous NaCl. When we carry out electrolysis of fused NaCl, we get sodium and a chlorine gas. That means we get pure metal by the process of electrolysis. Do you know? So many metals are produced every year by electrolysis process. So magnesium particularly is produced from seawater by the process of electrolysis. So electrolysis is very important process. What we do in electrolysis? We carry out a chemical reaction by passing electricity, and that reaction is of non-spontaneous type. So there are some quantitative aspects of electrolysis. Quantitative, that means we get metal, then how much amount of electricity is required to produce how much amount of product. That is the quantitative aspect of electrolysis. And this process is studied by the scientist Faraday. He gave us few formulas to find out the mass of product formed. So, today we are going to study about the quantitative aspects of electrolysis. So, let us start today's session. The mass of the reactants consumed or the mass of the product formed at an electrode during electrolysis can be calculated by knowing stoichiometry of the half reaction at the electrode. Do you understand by this? That means we are producing some metals or some product by passing electricity. And during this process, redox reactions are taking place. At one electrode, reduction takes place. At another electrode, oxidation takes place. And that reaction has some stoichiometry. What is stoichiometry? That is the coefficients we use to balance that reaction. For example, in electrolysis of aqueous NaCl, Cl minus gives Cl with releasing one electron. But to form chlorine gas, two Cl minus atoms are required, and at that time 2 electrons are removed. That means 2 Cl minus gives Cl2 plus 2 electrons. We write the reaction like this. At anode, oxidation takes place. And 2 chlorine ions are consumed to produce chlorine gas, 1 chlorine gas, that is Cl2, and 2 electrons. That 2 digit 2 is required, and that is the stoichiometry we say. So the coefficients used in any chemical reactions, those tell us about the stoichiometry of that reaction. So to find out the mass of the product formed at an electrode, we require stoichiometry of the half reaction taking place at electrode. And for that, some steps we are going to follow. We will see stepwise. We directly cannot calculate mass of the product. For that, we have to go through some procedure. We will see stepwise procedure to find out the mass of the product. So first step is calculation of quantity of electricity passed. To calculate the quantity of electricity, it is measured or it is denoted by coulomb, that is Q and measured in coulombs. So the quantity of electricity Q passed during electrolysis, and for that the amount of current I passed through the cell is measured. To calculate Q, we first require amount of current, that is I, passed through the cell is measured, and Second factor we require, the time t for which the current is passed is noted. So, to calculate Q, we require current I and time t. And the formula for that is Q equal to I into T. Q in coulombs we get if we measure current in amperes and time in seconds. So the first formula we got to find out the quantity of electricity passed, and that is Q equal to I into T. Now, second step we are going to calculate is calculation of moles of electrons passed. Moles of electrons passed. Now, the total charge passed is Q coulombs. That is equal to I into T, we know. But the charge of 1 mole of electrons is 96,500 coulombs. And it is referred as 1 Faraday. This factor is given by Faraday. He found out that amount, that for anything, the charge of 1 mole of electron is 96,500 coulombs. And we are passing total charge as Q coulombs. Then the moles of electrons actually passed can be calculated by using this formula. Q divided by 96,500. That means total charge divided by charge on 1 mole of electrons. That will give you moles of electrons actually passed. Understood? This is second step. Now, the third step is calculation of moles of product formed. Calculation of moles of electrons we have calculated. Now, calculation of moles of product formed. For that, we require some factors and we'll learn that. The first thing, the balanced equation for the half reaction occurring at the electron is devised. That means we have to find out that reaction which actually occurs at the electrode. Suppose from that reaction, we can easily calculate the stoichiometry. So the stoichiometry of half reaction indicates the moles of electrons passed and moles of the product formed. Both the things we can get. From what? From the stoichiometry of the half reaction. What does it mean? That means we have to write the half reaction taking place at that electrode. Suppose we take one example. For the reaction, suppose we have taken copper chloride, copper sulfate, and we are carrying out the electrolysis of copper. So, for copper, the reaction occurring at an electrode, suppose it is a reduction reaction, that is at cathode, the reaction taking place will be like this. Because Cu is in the second group, so it will Cu plus 2. And if Cu plus 2 to neutralize, to discharge that, it will require 2 electrons. So 2 positive charges are balanced by 2 negative charges. So electrons required we can take that. So for 2 plus, we require 2 electrons, so that both the positive charge will be neutralized and we get neutral copper. Same as we have seen in case of NaCl, where Na plus accepts 1 electron to give Na. As Cu has 2 positive charges, that is Cu always will dissociate as Cu plus 2 and SO4 minus 2 if we take CuSO4. Hence, to discharge Cu plus 2, it will require 2 electrons and the reaction will be like this. Now, this coefficient we have taken here and here 1, that means 1 copper ion requires 2 electrons to give 1 mole of copper, neutral copper. So this is the stoichiometry of the reaction. And for every reaction it is different. Now, that means 2 moles of electrons are required for the production of 1 mole of copper. Understood? And now, we can calculate the moles of product formed. The moles of electrons actually passed are given by the equation 5.68, which is that Q equal to I into T. That is 5.68. Now, the moles of electrons, or we are going to calculate the moles of product from the moles of electrons actually passed. And for that we require stoichiometry, as I told you. Now, what will be the formula? Or we will simplify it. One more entity is introduced, and that is mole ratio. To calculate moles of product form, one more formula is required, that is of mole ratio. What is mole ratio? The formula is like this. Mole ratio equal to moles of product formed in the half reaction divided by moles of electrons required in the half reaction. It is simple. Moles of product formed in the half reaction divided by moles of electrons required in the half reaction. Suppose we take this reaction. The moles of product form, how many moles of product form? Only 1 mole of copper is formed. How many moles of electrons are required? 2 electrons are required. Then mole ratio of this reaction will be 1 divided by 2. So 1 by 2 will be the mole ratio of this reaction. Understood? Because we got 1 mole of copper from 2 moles of electrons. Now, for the reaction of copper, the same I have explained here. For the reaction of copper, the mole ratio is 1 by 2. Now the actual formula of third step, that is moles of product formed. It is equal to moles of electrons actually passed into mole ratio. Mole ratio we got here. What is moles of electrons actually passed? Moles of electrons actually passed we got in the last step, second step, and the formula is Q upon 96,500. And we are going to multiply that by mole ratio. And mole ratio for every reaction is different because it can be calculated from the stoichiometry of the reaction. So we can carry out electrolysis of any electrolyte. Only thing is, we have to write correct anode and cathode reaction to calculate mole ratio. And by using that mole ratio and by multiplying that mole ratio to moles of electrons actually passed, we can calculate moles of product formed. But what is Q? Q is equal to I into T. That means I into T upon 96,500 into mole ratio. In bracket, I have written the units. I in ampere into T in second. That means we have to convert the time in seconds. Divided by 96,500 coulomb per moles of electron into mole ratio. So this is the formula to find out moles of product form. So third step, first step is quantity of electricity passed, second step is moles of electrons passed, and third is moles of product form. Now from the moles of the product form, our main aim is to calculate mass of the product. That means quantity of electricity required, that will give you how much mass of product that we are going to calculate. So the fourth step and final step, calculation of mass of product. We have already calculated moles of product. So the formula for mass of product is W equal to moles of product into molar mass of product. Here there should be equality sign. So W equal to moles of product into molar mass of product. That means in the previous step we got moles of product, only we have to multiply by molar mass of product. That means actually molar mass of that reactant. That means in case of copper, we have to multiply by molar mass of copper. In case of sodium, we have to multiply by molar mass of sodium. So simple is that. So W equal to moles of product, the previous formula, that is I into T upon 96,500 into mole ratio. Just we have to multiply by molar mass of product, and that will give you W. So W equal to I into T upon 96,500 into mole ratio into molar mass of product. So this is the formula, and based on this formula, numericals are asked in the exam. We are going to take a separate session for solving all the numericals in this lesson when we complete theoretical part of this lesson. Understood? Now, one more thing we are going to calculate. Suppose this is this formula is basically for electrolysis of an electrolyte, and from that we can calculate mass of the product formed. Now, suppose second aspect of electrolysis only, that suppose two cells containing different electrolytes are connected in series. Suppose two cells containing different electrolytes are connected in series. That means we have seen the figure of electrolysis of fused NaCl. Suppose we have taken same two cells in one container, one electrolyte like suppose NaCl, and suppose we have taken another container containing, suppose it contains copper sulfate. So we have taken two different containers containing two different electrolytes. The arrangement is same. That means two electrodes are dipped in those two containers, anode and cathode, and both the containers, suppose we have connected to the same battery, that is single battery. Why? Because we are going to pass same amount of electricity through both the containers. So the same quantity of electricity is passed through them. That means we have taken two containers side by side, and both the containers contain two electrodes, each anode and cathode, and anodes of both the containers are connected to positive terminal of the battery, and the cathodes are connected to the negative terminal of the battery, same battery, because the quantity of electricity passed through both the cells is same. And when we pass electricity, same quantity of electricity goes to anode and cathode of the corresponding cell. And as usual, at anode there is oxidation, at cathode there is reduction. But we are going to say the quantity or quantitative aspect. That means we are going to find out the mass of the substance produced at each electrode and comparison between these two. So let us start with the second aspect of electrolysis. So same quantity of electricity is passed through them. The masses of the substances liberated at the electrodes of the two cells are related as given below. Now I have told you we have taken two different electrolytes. Suppose in the first container we have taken NaCl, in the second we have taken copper sulfate. That means sodium is we get at cathode, copper we get at cathode in the second cell, and the masses of the substances liberated we are going to calculate. And for that we have this formula W, mass of the product, but we are going to relate these two cells with each other. So the masses of the substances liberated at the electrodes of the two cells are related as given below. The mass of the substance produced at the electrode of the first cell is given by the same formula. W1, suppose we say Q upon 96,500 into mole ratio into M1. M1 is the molar mass of that product formed in the first cell. W1 is the mass of the product formed in the first cell. In the same way, we can write about W2 also. So, hence, Q upon 96,500 equal to W1 upon mole ratio 1 into M1. We have just rearranged this equation. So this mole ratio 1 into M1 has been taken to this side. So this upon this equal to W1 upon mole ratio 1 upon into M1. Similarly, mass of the substance liberated at the electrode of second cell, W2. It will be same only in place of W1, M1, we are going to write a 2. That means Q upon 96,500 will remain as it is, equal to W2 upon mole ratio 2 into M2. As this Q upon 96,500 is common on the left side, we can equate these two. This is common, hence this will be equal to this. So, M1 and M2. What is M1 and M2? M1 and M2 are the molar masses of the substances produced at the electrodes of cell 1 and cell 2. That we know, molar mass we know, that is fixed. So, As M1 and M2 are known and Q upon 96,500 is same for both, we can write, as I told you, W1 upon mole ratio 1 into M1. That is right side we can equate because left side is same for both the equations. So W1 upon mole ratio 1 into M1 equal to W2 upon mole ratio 2 into M2. And so this is the formula we got. If we connect two cells containing two different electrolytes, then the masses of the product formed can be related as W1 upon mole ratio 1 into M1 equal to W2 upon mole ratio 2 into M2. The numericals on this formula can also be asked. Now, the time for assignment. How will you calculate the moles of electron passed and mass of the substance produced during electrolysis of a salt solution using reaction stoichiometry? The question is like this. That means you have to write all the 4 steps. Calculation of quantity of electricity passed, then calculation of moles of electrons passed, and then calculation of moles of product formed, and finally the mass of the product formed. For single electrolyte, I haven't asked question on the second formula, that is if two cells are connected in series, that we will solve directly the problems or numericals based on that. Write down just in detail. If you open your textbooks, you will get all the details. So write on that in the today's assignment. Thank you.